Okay, so hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company, provide technological solutions across the world. Now see, this is our another session in bootcamp, that is decision tree in machine learning, right? Now see here exactly what is decision tree in machine learning. See, in our previous sessions we have been learning about how to take the data from the company and how it is broken into two parts, right? So in PyTorch the things are different, in CNN the things were different. Here this decision tree is used for taking the decisions. Just I'm giving you an example. For example, a person who is performing in an comedy show, like a person who is performing in any concert or any function. Now we are having his history, like in which type of functions the people go to watch him, or how many times the people go to watch him. So based on that, how do we predict the data? Or just take another example. For example, I am having the company sales order data. Now in that sales order data, how much is the probability that another few months what will be the profit, what is the profitability for the next upcoming future, right? So this is how we predict the data. Basically this machine learning, what it does, it takes the previous historical data and apply some algorithm in that, and after that algorithm it predicts what will be the data. For example, let's take an example. I have for example, one student is there, and from since first standard to 10th standard, 9th standard, his performance like 52%, 58%. At the time of 11th or the subject selection, if he says, then his parents will see his past background performance, and based on that the parents will say, okay, don't take mathematics, or take something else, but don't take engineering, right? Or don't take medical field. So this is how our prediction. Now we human, we take prediction based on the past historical data, right? Because we are humans, it is very easy for us to take the decision on the past history, right? But what happens when we want to put the same capability into the machine also? Now the same capability in the machine, it's not so easy. So that is why some algorithms were designed, right? Now see here, that is what I am going to explain you today. Decision tree is a supervised learning technique that can be used for both classified and regression problems, right? Now this decision tree, now there were two techniques, linear regression and one more, random forest regression. But among these, the third type of regression, that is a decision tree regression. This type of regression is most accurate than the other two, right? We will, in upcoming sessions, we will see those two types of techniques also, right? Now see here, decision tree is a supervised learning technique that can be used for both classification and regression problem. Now here you can see the decision node, right? Root node. The root node means the point when we provide the input to the machine, right? Now based on this decision tree, right, this is called the subtree, and these are called the leaf node when there is no any other node beyond this. Based on this it takes the decision. For example, again the same is example I am taking from the real life example, right? Real life, let me give you one real life example. In real life example, what happens? Suppose a student asks his parents that he wants to take admission in an engineering college in any metropolitan city. Now based on that, the parents will take a decision based on different criteria. For example, whether they are having sufficient funds and budgets to take the to pay for the charges of hostel, right? To bear the charges of hostel, to bear the charges of dining. Secondly, whether their child is capable enough to handle the ragging, he is not having any fear. but the thing is that parents were not having that much capital to send him. So these are called different criteria. Same thing is here. Decision tree also works on take different criteria, and ultimately at the end the decision tree algorithm, it takes the decision, right? Now see here, if I show you like this, what is supervised learning? Now supervised learning is a machine learning paradigm where a model learns from labeled data, meaning each input comes with a corresponding correct output to predict outcomes or recognize patterns. See here, first of all, labeled data, we have given input raw data, and label is here like camel, elephant and cow. Okay, now training, this is here the algorithm works and it processes and suppose if here is the desired output, what will be the desired output is either elephant, camel or cow, because only these three types of animals are given here in the picture. Suppose if any other third type of animal is also given like pigeon or peacock, anything else, it would be shown here also, right? So this is how the supervisor training data set and then desired output is given. Based on this, it gives you the output. Clear? It will become more clear once I take you to the practical part. Now decision tree terms. Now look at this root node, these are the branches, condition check, leaf node, decision point, right? Now let me explain you the same thing with your daily life, a very simple daily life scenario. Child has secured good marks and the child is willing to do his engineering. Let's take any metropolitan city, it's up to you. Now this is the root node. The problem is whether to send the child or not. So there are two conditions: either your child is courageous and brave enough to live alone in a different city, then whether the parents are having enough funds, right? So if both the conditions are successful, then there will be the output that is yes, right? Leaf node, decision point, leaf node, decision point. Here the decision points are taken and then there the output will be yes. If any one of this is no, then it will be no. Now example of decision tree, let me show you one example. Age 36, experience and rank and nationality and go, right? Here is an example taken. Now see here, how many this is no and yes, based on the ranking, nationality, experience, for example age. Now no matter whether the name is given or not, that doesn't mean. Based on the algorithm, what it works based on the data what is given to the algorithm. For example, let me give you one more example. Suppose in a college, in a college there are certain the student comes from different families, right? Now based on the percentages, based on the historical percentage, like the college has given you the percentage, like this person is scored this and his father was this and his mother was this at this profession, and everything is given to you. Now based on that data, the machine learning takes the decision. Not machine learning, we humans also we take the decision that okay, the person who receives a good school education, there is a bright chance of that person to achieve more marks, and the person who receives his education is in a very simple school, there are less chances. So same thing can be obtained from these algorithms also, right? So algorithm also derive the solution based on this criteria only, right? It takes the data and based on that it derives the output. First of all, let me show you this. What is this genie, right? So you might be thinking exactly what it is. So first let's skip to this slide. Let's jump on this slide. Now see, what is Gini impurity? Gini impurity is a measurement used to build decision tree to determine how the features of a data set should split nodes to form the tree. Now see here, positive value, n total values, and y is the negative value. Now this is the formula which is, now see here, this is the formula which is derived, right? So if you see here, age, youth, middle age, senior, yes, 2, no, 3. Now what will be the impurity? That impurity is calculated here, right? And based on that, different leaves are created. The impurity is less. Look at this, 0.343 is less, and here 0.440, this is high, so you will go here, right? This is the best. Then students, same thing here. If you see the Gini impurity, this is 0.24 and this is 0.48, right? And the impurity is this. So based on this, it calculates the data, and just a second, here, based on this, it calculates the data and it creates the nodes and leaves, all these things, right? So this is completely in-depth technical, so we should go on this practical part. Okay, now in this practical part, let me show you, I will show you how this decision tree works, right? So how this decision tree works, first of all, we have to take the finance data. Now this finance data, for example, one company is there, and that company is working on ERP, right? So in that ERP, we are having that data of transaction, sales data. Okay, whatever the transaction data is there, we have taken. Now after that, what will happen? We will take this data, and based on this decision tree functionality, we will derive exactly what will be the output. Look at this, this is the error, and in this way we will see what will be the difference, actual value, predicted value, and based on this you will see here, this is most accurate data, that is 90% accuracy is here, right? So whatever, that is what we are doing. Our today's agenda is to see exactly how the decision tree algorithm works. Clear? Okay, now let's start. Now before that, before going further, what I will do, I will create one new IPyNup file, right? Interactive Python notebook file. Okay, so here is, we come here, decision tree regression underscore bootcamp. I will make one rename also here. First make it here is. Now first of all, what we need all the necessary libraries, right? So we need the libraries first. So I am writing it in front of you, so just take this here, and now right now we need only NumPy, Matplotlib, and Pandas, right? So we are importing only 3 libraries. Now many times it happens that these libraries are not installed in the laptop, so you have to install it, right? Now import NumPy as NP, Matplotlib, PyPlot as PLT for plotting, right? Import Matplotlib PyPlot for plotting our result. Import Pandas for importing CSV file, right? CSV file import, right? We need to import the CSV file. Now let's see here again. Here we go, and then now see what I have done here. I have already, there is a file, CSV file, and we are just importing that CSV file, and this is called the data set, right? Data scene. Yes, just a second. Now see here, financial data, equal to pd.read csv. pd.read csv is the command where it will pick the csv file and it will read out all the data from that excel sheet and put it inside the data frame. So right now fin underscore data, that is financial underscore data, it's a data frame, right? Now see, segment, country, item name, item price, total revenue, profit, and the month number and the year. Okay, now this data set is given to you. Now in this, what happens, we have to apply the decision tree, right? But since here, okay, now what we have done, financial data equal to pd.get dummies, financial data dot d type int. Now we have created the dummies. I press the enter button. Now see here, everything is converted into dummies, right? Every number, no, not number, every alphabetical data is converted into the numerical data. That means a specific number is assigned to that particular data, right? So now it is done here. Now see, now what next? Now again we have to predict the profit, right, for the next future. Now for future we have to predict the profit. So again the same thing, we have to separate the data. Now separate the data means independent variables and dependent variables. Profit is a dependent variable and remaining all are the independent variable, right? So independent variable means they already exist, they are not dependent, like for their existence some other data is required, it's not necessary. So that is why they are called independent variables. Dependent variable means, for example, profit. So how much is the goods sold, that will be the profit. So this is okay. Now let's move ahead. Now if I go here, so that is why we have divided. Now see, profit is a dependent variable and remaining all is the independent variable. So what I have done here, I have kept all the dependent variables into X and remaining okay, I'm hitting the enter button. Okay. Now if I put here X, now let's see. Okay, now if I show you this from SQL model selection, now we have divided the data into two parts, right? Now we have divided the data into two parts and then we are doing here now see again here. Now what I have written here, from sklearn dot tree import decision tree regressor. We have to import a file that is decision tree regressor. What it will do, it will work on this to generate the regressor equal to, now see, create a regressor object. Regressor equal to decision tree regressor bracket random state equal to 0 and then fit the regressor with x and y. Regressor dot fit x train y train. Okay, now if I put here, right, now look at this, it is done. Now see here, if I hit, now see, regressor will give you the exact accuracy, right? Regressor, now you can see here 90%. 90% is the test, right? Okay, now here is, after this After this, now it is sure that now we are sure that 90% is the accuracy of this. That means it's quite accurate. After this, Y prediction and Y test. Now see, with the help of this regressor, we are predicting the data. Okay, now you can see here Y prediction equal to regressor dot predict X test and Y prediction Y test. So if I put here like this, so this is how the predicted data and the test data is here, right? Now if I show you this predicted data frame equal to PD dot data frame actual value equal to this, predicted value equal to this, and difference is Y test minus Y pred. So what we will see here, now if you see actual and predicted 941, difference is 0, 846, 826, and the other is 974. So you will see there is a difference of minus 148. After that 286 minus 286, 0. Right, you can see here the difference is very less. Okay, now the difference is very less. Now that means it shows that it's a completely perfect. Now what I am going to do here, I will use the plot, PyPlot, right? So sklearn import tree, there is one more library in that, in sklearn, that is import tree. Now tree dot plot tree. Now this tree dot plot tree equal to regressor, so we will pull the regressor also, then the future feature names, that is item, price, total revenue, month number and year, right? And based on that we are plotting the data. Now look at this, just a second, we need to wait for 2 seconds more. Okay, look at this, this tree is also generated, so I will explain you exactly what it is. Here you can see total revenue, here it is coming, right? And finally you see here the tree dot plot tree equal to regression features names. These features names we have given, based on that only you have to calculate the data, right? So it calculated the data based on this criteria. Suppose again I am giving you, I am relating this same example with real life example. For example, if I give you the details of only 2 things, that is what is the financial condition of a student's parents, and second is how much the student is brave enough or the courageous enough to live in another city, right? This, on the basis of these 2 things, you can easily identify, okay, whether he should go there or not, right? After that we have executed it many times, or almost every row, right? Okay, now here you can see so this is how the decision tree is created, and decision tree is much better than the remaining 2, that is the random forest and linear regression, right? So let's have a quick recap and then we will conclude the sessions. Okay, now see here, first of all, decision tree. What is decision tree? Now it is clear to you, right? Decision tree is a technique right, in which we take the decisions based on the input. Okay, after that we import so many libraries. One is the pandas, another is numpy, third is the matplotlib for plotting the data. Then what happened, then we will import the Excel sheet. After importing the Excel sheet, we will see that there are so many alphabetical values, so we will convert all the alphabetical values into the numerical values. Once it is done in numerical, now in this numerical values we will separate the data which is independent and which is dependent. After that, we separated the data, we stored it into different variables. After that, we have to bring the train test variable, in which the train test variable means training the data and then the testing the data. Okay, so now next is regression fit. Yes, we have to take the decision tree regressor, right, and in that regressor you will pull all the data, and based on the regressor you will create a function regressor dot score, and you will see here the score is it should be, here it is, it should be negative, either it should be negative or positive. Regressor dot predict x y prediction and y test, right. After that prediction pred df equal to pd dot data frame, whatever the data frame is there. So based on this, whatever you provide them the information, right. After that, it will write here actual value and the predicted value, right. So after this, after having a look on the differences, then from sklearn import tree, and then tree now the final what final we do, we see the difference, and then we will plot our data, and then after plotting the data, it will look something like this. So guys, my suggestion to you is watch this video twice, thrice, right, and still if you face any error or issue, let me know, I will resolve that. Okay, so for today we have seen the decision tree regression, and tomorrow we will see some new topic. And those who are new to this channel, please subscribe the channel. Thank you.